Okay, here we go. This is lesson 3.2, and it deals with the three trigonometric functions and how they apply to our coordinate axis here. So the first thing we have to remember is this whole idea of SOHCAHTOA. Most of you probably remember that this would be sine is equal to the opposite over hypotenuse, that the cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. And these sides, remember, have to do with which angle you're looking at. So if you're looking at angle theta here, this is a right angle. You shoot out of that angle, you find the opposite side. That's the adjacent side, and the hypotenuse is always the long side. Okay, so we have to remember this SOHCAHTOA stuff when we start looking at a coordinate axis. So what we're going to look at now is I just have the first quadrant here, and if we use this idea of SOHCAHTOA, here's our angle theta in standard position, right? This being the initial arm, this being the terminal arm. So if I wanted to find sine theta in this case, notice that would be y over r. And if you look for cos theta, it's going to be x over r. And if you look at tan theta, it's going to be y over x. Some of you might be wondering where that r came from, okay? That's simply the hypotenuse in this situation, and we can always find that value if you remember using Pythagoras, which would be x squared plus y squared is equal to r squared. And the r value, you got to understand that this r value is always positive, okay? And we can get that from the Pythagorean theorem too, because if you're squaring all the numbers, everything becomes positive, right? So let's think about what we talked about yesterday, or in the last lesson, okay? We showed you some reflections of these points. So if I have a point here that is x and y, and I reflect that over the y-axis, it's going to come over here, and it's going to be negative x and y, right? If we flip it down here, it's going to be x and negative y. And if we flip it twice into this third quadrant, it's negative x and negative y. So hopefully you remember me talking about how the sine, cosine, and tangent repeat in each of these quadrants. We looked at our calculators and saw that the numbers were often the same, or usually the same, or actually always the same, but it's the signs that changed, okay? And the signs changed because of these negatives here. So this is what we're looking at today, all right? Now, let's just jump to this big description here. This is an example. This is a big table, okay, that shows you the signs of all the trig functions in each quadrant. So if we're on this side, your x is positive. On this side, your x is negative. Similarly here, above the x-axis, your y is positive, and below your y is negative. So if we look at the sine, cos, and tan in each of these quadrants, we're still looking at these ratios, the y over r, x over r, and y over x, but we're looking at the signs as well. So in this case, first quadrant, just like what we had up here, let's look at the second quadrant. So sine theta, if it's y over r, my y is positive, so it's still just y over r. If you look at the cos of this angle, your reference angle, again, okay, because that's the reflection part, the cos is the x over r, but in this case the x is negative, so it's negative x over r, which means that your cosine is negative in the second quadrant. If you look at tan, it's y over x, and your x is negative, so your tan is also negative. The only thing that remains positive in that second quadrant is the sine. Now, before you watch me fill out these other ones, see if you can fill out these other trig ratios in the third and fourth quadrant. Pause it. I'll finish it off. Have a look. See if you did it. So sine now is y over r. Y is negative. Negative y over r makes the sine negative. Cos is negative x over r, so that means that that's negative as well. Tan is negative y over negative x. A negative over a negative is a positive. Boom, we got tan as the positive trig ratio in the third quadrant. Fourth quadrant here, it's the y that's negative, x is positive, so sine is negative y over r. That makes it negative. Cos is x over r. being positive. Tan is negative y over x. That makes that negative. So you'll notice that in each of these other three quadrants, only one of those trig ratios is positive. And they're all positive in the first quadrant. So we have a way of remembering that. We can summarize it with a small little graph like this, where they're all positive, sine is positive, tan is positive, cos is positive. Now, ASTC is this rule starting in the first quadrant. Some people call it the cast rule, but that starts in the fourth. I don't like it so much. I've talked about creating mnemonics for these things. I've had people come up with a small Tibetan child, all saints, take charge. If you can come up with a mnemonic here that makes you remember the signs in each of these quadrants, I'd be happy to hear it. So ladies and gentlemen, let's have a look at a couple questions here. Get rid of that. Here is one example. If I have cos theta is negative 5 over 13 in the third quadrant, find sine theta and cos theta. What we need to do is sketch it. Okay, 1, 2, 3, third quadrant, 5 over 13. So cos theta is equal to adjacent over hypotenuse, or x over r, right? So x is 5, right? So that's a negative 5, and your r will be 13. Your hypotenuse will be 13. Is there any way that you can figure out how to find your y value here? Okay, because you're going to need that if you want to find your sine theta. Sine theta is y over r, and tan theta is y over x. So we need a y in each of these cases. Hopefully you can see that Pythagoras would be the solution here. Minus 5 squared plus y squared is 13 squared. That's 25. 13 squared, 169. Y squared, 169 minus 25. So you get y squared equals 144. So y would equal 12. We get 12 here. And now your sine is y over r. This is a negative 12. So it's negative 12 over 13 would be your sine theta. And your tan theta would be minus 12 over minus 5, which is just 12 over 5. Oops, that's off the thing there. There we go. Okay. So the key is to make the drawing first, put the right values in the right place, do some trigonometry or some Pythagoras to find a third side, and then simply use your trig ratios. SOHCAHTOA. Okay, let's try another one here. Tan theta. Find tan theta if sine theta is 1/3 in quadrant 2. So now we're looking at the second quadrant. Sine theta is y over r. So your y is 1 and your r is 3. So we'll go like this, where that's 1 and that's 3. And again, we're going to have to find this third side. So x squared plus 1 squared is 3 squared. X squared plus 1 is equal to 9. So x squared is equal to 8. So x is equal to root 8. Or if you remember how to simplify radicals, it's 2 root 2. So in this case, your x is equal to negative 2 root 2 because it's on the left side. So if we're looking at, we're looking for tan theta. So tan theta is equal to y over x. In this case, it's 1 over negative 2 root 2. And that would be the answer for this second question. I think there's a couple more under here. Let's have a look. Yes, there is. Sine theta, if tan theta is negative 2.135 in the third quadrant. So we're down in the third quadrant again. Remember, tan theta is y over x, right? So it's going to be negative 2.135. Does that have a denominator? No. So we'll put a 1 there, which means that we're down in the third quadrant, so it means it's going to be a negative 1. And then my y will be negative 2.135. Okay, this is a negative 1. All we have to do is find that hypotenuse again. So -1 squared plus -2.135 squared is equal to r squared. Let's put out our calculator here. 2.135 squared gives me 4.56. So 1 plus 4.56 is equal to r squared. 5.56 is r squared. R is the square root of 5.56, and I get let's call it 2.4. Okay, so now we're looking for sine theta. Sine theta is y over r, or -2.135 over 2.4. And you can get an answer. Oh, let's slide that up for you. And then we can just do that division and we'll get a value for the sine. Last question I got on here. Okay, it's a little bit different, but if you understand what it is we're doing, it shouldn't be that tough. You understand how to plot points, hopefully. 5 and -12. 1, 2, 3, 4, 5. 9, 10, 11, 12. We're down here. This is 5, -12. Okay, so what we do is we create an angle here, like this, where this is my x value, which is obviously 5. And this is my y value, which is -12. How do you find your r? Well, if we do some Pythagoras again, you're going to have 5 squared plus 12 squared is r squared. You're going to end up with r is equal to 13. So if you want to find the 3 primary trig ratios, that would be sine theta, cos theta, tan theta. And you know the ratios, okay? You know the ratios. The 5, the x is positive, the y is negative, so sine is -12 over 13. Cos is 5 over 13, and tan is -12 over 5. You're going to have a lot of other types of questions that you're going to have to work out too. Hopefully what we've done here will be able to give you a good head start. Any feedback about this video would be greatly appreciated. I'll see you guys tomorrow.